Hello, welcome everyone. Happy Halloween. My name is Daniel Moyer. I'm one of the sales support trainers here at Briggs Stratton Energy Solutions. Today, what we have for you is off-grid living with simplified power. Couple housekeeping items before we begin. This is a NAPCEP accredited course, so if anybody here is looking for their continuing education credits, just wait till the end of the presentation and my email will pop up and we can go ahead and get you the credits. Email that email with your full name, spell it out for me, full first and last name, so we can get you the proper name on your credits as well. So as we jump into this, let's go ahead and just take a look at what we're going to talk about today. Kind of the history of the off-grid, the type of off-grid systems. We're going to do some practice on sizing an off-grid system. Lead-acid battery replacement, which is a really popular thing for a lot of existing off-grid customers. Share with you some of our online calculators and resources, and then jump into some of our products. So again, welcome. Happy Halloween, everybody. If there's any questions during this talk, go ahead and put the questions into the Q&A chat feature. It's either at the bottom or the top of your screen. We've disabled chat, so use the Q&A, and we'll go ahead and get started here. One thing I just wanted to start off really quickly is we got a great incentive program for you guys. It's $1,000 off your first install. You don't have to be part of our Elite IQ installer program to take this $1,000. But if you do happen to join the program, we're going to give you $1,000 off the first install, whether you're part of the program or not. But if you are part of the program, we're going to give you an additional $100 off every battery you purchase, and that's indefinite. So as far as I can, as right now, we got it going as completely far out. So $100 off every battery you install. Go ahead and scan that QR code. We'll go ahead and get you into the program, put you on the maps, promote your company as well. If anybody's looking for questions for sales, there's the sales number down there at the bottom. So please join. I'd love everybody on this call to be part of the program as well. So let's go back in time a little bit. I went, as preparing for this talk, I went back to some of my old Home Power magazines. If anybody had a subscription to Home Power or read Home Power, please put it in the Q&A. Let me know how long you've been a subscriber. They're out of print now, but all of the articles are in magazines. Subscription, the issues are still available online, and there's a link right there. Everybody who attends this is going to get not only a recording of this webinar, but also a link to all of these slides. But I went back to 2001, and I was taking a look at some of the old ads in this Home Power, and I've came across this one. I mean, look at that. Siemens 100-watt solar panel is $477 a watt, $4.70 a watt. That's just for the panel. That's not including the racking, the wire, the installation labor, any of those other parts and pieces. So it was expensive. And back in the day when it was expensive, it really required us to look carefully at our loads, carefully at what we were doing for the home's consumption. But if you think about it, really a lot of where solar, this whole industry got its start was in the off-grid industry. And the first consumers were really people, the pioneers, living up off of off-grid systems. A lot of times you just had a generator, right? You'd start the generator up and the generator would run during the day. And then you would shut the generator off when everybody was ready to go to sleep. But some of these pioneers on the off-grid industry are the first ones to leverage some of these old solar photovoltaic panels, some of these old trace inverters, old charge controllers. So this is in a lot of ways where the roots of our industry started, is in the off-grid industry. So I thank you all for being here today. There's a great organization, Solar Pioneers. They have a great documentary called Solar Roots, which should be coming out as a public version here shortly, that talks about this very concept, right? That we started in the off-grid industry. You guys were the first ones to use terrestrial solar, I would want to say, and move forward into what we know now as grid tied. Really, the generators were loud, they're noisy, and they also used a lot of fuel. And so that fuel is what kind of drove people to start to use the off-grid. I do want to say this, that I'm really excited to be part of Briggs & Stratton, that now we can offer you these energy storage batteries that are reliable, safe, and very cost effective. But Briggs and Stratton's history goes so much further back than that. And I found this in our museum. So if anybody's ever out in Milwaukee, Wisconsin, let me know, and I'll make sure you guys get a tour of our museum that shows a lot of the innovative products that we come up. And one of them was a gasoline-powered washing machine. There was actually like one of our lawnmower engines in the bottom of this laundry machine. And so it really kind of speaks to the history of Briggs and Stratton, our legacy, and the resources and the size of this company that can support you, the installer, as you go forward, partnering up with us. They actually continue to produce this gasoline-powered washing machine all the way into the 80s, I'm sorry. It does go back, though, further than that, right? After these gasoline-powered washing machines, we really do have a long history in batteries, right? Batteries are not new to us. We've started off in a long way, and there's a great Jay Leno actually came out and test drove one of these electric hybrid cars we produced way back in the 70s. And again, this is at the museum if you like to look at it. But we've progressed, right? We've now innovated into these battery-powered lawn equipment, and we have a sister division, Vanguard, that produces batteries for riding lawnmowers, for rototillers, for all the different applications that you would see. Additionally, and in parallel to us, is our SimpliPHI Power division, which produces the lithium iron phosphate batteries that are used for homes. Briggs and Stratton bought SimpliPHI Power about 3 years ago, and SimpliPHI Power has its roots over almost 14 years now, where we innovated. We started off in the film and broadcast industry. We've now progressed up to these lithium-ion batteries for homes, and our most recent offering, what you see on the screen on the far right, is our new stacking 6.6 battery, and we'll get into some more of the details here in a minute. I will say this, that the Vanguard batteries are cobalt-based chemistries, which is appropriate for when you want a high energy density, lightweight, something that can discharge quickly. They're smaller batteries overall, so cobalt-based chemistry makes absolute sense, just like in our phones and our laptops. But when we're looking for stationary home power, either for backup or for grid arbitrage, what we want to leverage is lithium iron phosphate, which is something SimpliPHI Power was an innovator in and has always leveraged in our products. Another great home power, again, put it in the chat if you've ever subscribed or read a home power magazine. I found this article, and Randy Udall, I don't know if anybody's ever heard of him, but I found this great article. For decades, cheap propane has been the dirty little secret of off-grid living, right? You could use propane to run a generator, to use an absorption-based refrigerators, the clothes dryer, the oven, the stove, the heater for the home. All of these were propane. And really, Randy kind of hit it on the nail, the hammer on the nail, the head of the nail. Propane has become expensive, right? Here in California, where I'm located, it could be anywhere from $3 to $4 a gallon. And what we want to do now is leverage photovoltaics to then charge up batteries and power the home. And one thing I wanted to mention here is that I worked for a long time at Sunfrost Refrigerators. Larry Schuessler, who was one of my mentors, was the first one to be one of those pioneers for the off-grid industry, that we developed DC 12 or 24 volt based compressors for off-grid systems where we didn't have to leverage the inverters. Back then, the inverters were not very powerful. They're relatively expensive. So we had DC loads on the system. And we're going to look at a little bit what that architecture looks like here in a minute. Another great ad I found in this exact magazine issue was an article, an ad for NABCEP. And again, anybody here is looking for NABCEP. This is NABCEP accredited, and we're going to have the credits issued at the end of this talk. I am joined by Mike Schaefer. Welcome, Mike. Mike's going to be taking a look at the chat, the Q&A section. So again, if you have any questions or comments, or if you've ever read a home power, please go ahead and put that in the Q&A, and Mike will be able to check that out. One interesting thing I've started to realize is a lot of the off-grid principles that we now know a lot about is now starting to apply to grid-tied homes. There's a lot of homes out there in California, Hawaii, and other parts of the country that are starting to get rid of their net metering policies, where you're no longer able just to export your energy back to the grid and get that one-to-one credit. So people are doing everything in their power to not export electricity to the grid and not import electricity to the grid. So essentially, you're an off-grid home. Of course, a lot of times in the winter, when there's been a big storm and you got all the Christmas lights on, you are probably going to import electricity from the grid. But a lot of the principles that we're going to talk about today are now starting to apply to these net metering policies. I will say this, that it is unfortunate that a lot of other states are starting to adopt the policies that California and Hawaii have taken to get rid of their net metering policies before your states have reached a solar saturation, before they've started to see this so-called duck curve where solar is producing during the day, but then everybody comes home at night and uses all of their loads. So I would encourage everybody on this call to join any of their local solar association programs that are out there lobbying lawmakers to pass bills, legislation that's going to keep solar and storage strong in your states. Couple home power articles here. Again, these two articles here coincide with the first net metering policies that came online in California, which was in the mid-90s, and again when we revamped it for NEM 2.0. I do have other trainings. Stay tuned for those where we spend the entire hour talking about net metering policies and how has that impacted our industry. I currently still live up here in Arcata, California, home to Sunfrost. And this is picture what you're seeing. There is a home up in Humboldt County, right? We're up in the redwoods. We're off grid. And I hope that this would be my home someday. And if it was, I would look carefully at what is the cost factors that it takes to get utilities out to the land. I'm not getting natural gas, right? There's no natural gas pipes out there, but there definitely might be some transmission lines. How far away is that from the property? And how long am I going to have to trench? Maybe I have to go through somebody else's property and talk about easements or right-of-ways. Maybe that power line doesn't have a transformer where I need to access that electricity. What is that going to cost? So the amount of money it takes to get utilities out to a remote property like this is going to be substantial. I would also argue that what it's going to take to put in a robust off-grid system that's going to make you feel like you're not living off-grid is also going to be have a substantial cost. Although with the drop in photovoltaics, it's no longer $4.70 a watt for that solar panel. Solar panels have come down in price. Inverters, charge controllers, the advent of hybrid inverters like Solarx and others have really made the ability for inverters to handle a lot of AC loads on the house possible. I would also argue that safe, reliable, cost-effective, long-lasting batteries like ones offered by Briggs Stratton Energy Solutions have made these living off-grid opportunities much more possible and much more convenient as well. So again, a lot of times back in the day, people would just use generators. They would run the generators during the day and then shut them off at night. That actually still could be an opportunity. What would even make a better opportunity is when we combine both of them together so that we have an energy storage system that's backed up by a generator. And a lot of these hybrid inverters, a lot of the other solar components have two-wire signal to start. They can start up that generator, run it hard, charge up the batteries, and then shut the generator off. So by combining both of them, I really see a lot of resiliency built into it. And you're saving that propane truck from having to make it up your dirt road up to your property as quite often as it would be if you're just running on the generator alone. Is anybody still here doing micro hydro or micro wind? Please put it in the Q&A. Let me know if this is something you're doing. These are some of I found these in an old home power article. And I will say this, that NABCEP still offers certifications for these two technologies. Again, I don't think many people are going to chat, put that into the Q&A, but please do if you are participating in this. Why? Because photovoltaics became so cheap. Solar panels right now are maybe 50 cents a watt. A lot of these systems had all of them have moving parts. They need dump loads. They need special charge controllers. You got to clean out the screens and the water catchment. So I do see those an opportunity if you're in a piece of property that maybe has running water, that maybe does have an open field with wind. Some of these absolutely can still be leveraged. They're not a big outputter, but they output continuously, usually sometimes 24 hours a day, and can really add to the system. I will say this, that a lot of the solar hybrid inverters actually can take wind as an input, and they have a special tab for that on some of their configuration screens. So let's jump into some of these off-grid systems. And I would argue that the first off-grid solar system that any of us have had was a calculator, right? It was a little calculator that had a little solar panel on it. That essentially is an off-grid system. So are these other examples, right? A little solar-powered radio or a little solar-powered lantern. Happy Halloween, everybody. Those little pumpkins have solar panels on them, probably a little charge controller and a battery in them, and a load, right? The LED light that's lighting up that little pumpkin. These are all some of the most basic off-grid systems possible. Another off-grid system is some of our Big Jenny and Little Jenny, which you see up in the top right corner. These are a lot like the Goal Zeros or the Yetis that you see, although I think Yeti might be a cooler. These are off-grid systems, right? They have the panels, the batteries, the charge controllers, and even an inverter. I would argue these types are more expeditionary type ones. So this is the most basic. Let's step it up a little bit. Another type of off-grid system that a lot of we might recognize is kind of the day use systems. And the most popular one I've seen in this kind of realm is pumping water. So you got a water pump. It can either be a below ground or an above ground pump, and you simply pump water uphill. You usually have a linear current booster in there to boost up that the amps, and then you pump up the water uphill to a tank, right? And a water tank that's sitting up on a hill is a battery. If you think about it, right, the volume of water in that tank is kind of your energy capacity. The height of that water tank above the load or above the shower head or the toilet or the sink is the voltage, right? The pressure in the pipes. A lot of them also incorporate a float switch so that the pump will shut off when that tank is full, so you don't start overfilling that water tank. So again, we're starting basic here and we're getting more advanced. Another opportunity I've seen used for these kind of load systems is fans, sometimes for greenhouses as well, or in a house as well. Let's get a little more advanced, everyone. DC architecture. This used to be really popular in a lot of the off-grid systems when we had very expensive inverters and batteries were more expensive. And what we would do is we would use no AC loads, right? A lot of the inverters back in the day were modified sine wave inverters or square wave sine inverters, and inverters weren't very powerful. They were expensive. So let's just run everything off of DC. We got a solar panel. If you're living off grid, you probably don't have that disconnect there, but you might. I'm feeding it into that sun saver. And the reason I chose that exact Morningstar sun saver is that it has a built-in low battery voltage disconnect. So we feed in solar, we feed in our battery. You probably don't need this little breaker here. Why? Because our batteries here have breakers built into them. I added it anyway in case there's any code inspectors on the call here. But what we do is then we take off the DC right out of the low voltage battery disconnect over here. I feed it into that Blue Sea Systems kind of power distribution block right there with the fuses, and then I feed it up to my my loads, right? DC light bulb, for example. Down in the bottom right corner, though, I have my DC refrigerator. And if you look carefully, if you notice, I didn't feed that DC refrigerator into the low voltage battery disconnect on that Morningstar charge controller. Why? Because that charge controller is only rated for 15 amps coming off that load, and the surge on that compressor is probably going to exceed 15 amps DC. So what I want to do is run those directly off of the battery. And a lot of times those refrigerators, those DC refrigerators like Sundancer, like Stecca, usually have a low voltage battery disconnect capability built into the controller on the side of the compressor. I kind of think that this architecture may be coming back into our realm here. Why? Because of the advent of these USB-C, the advent of using power over Ethernet. If you think about it, now that our phones kind of plug in with USB-C, those are capable of almost 100 watts. So the idea that maybe instead of a wall outlet in your house, you have and an AC coming out of it, you have a couple of USB-C ports. And you plug a lamp into that, or you plug your phone, or whatever the case may be. There was a really great article done by NREL that if anybody is interested in reading, it's a great talk about how we might kind of go back to some of this DC architecture. Of course, we're probably still going to need AC outlets for some of our larger motor loads, like an oven or a dryer or some of those other loads. But interesting to see that concept coming back around a little bit. Mike, stop me at any time if you see any great questions coming in, and we'll be sure to address them during the talk.
Yeah, Daniel, we've got a few questions. You can hear me okay?
Yeah, great.
Yeah,
Happy
so
Halloween, Mike.
Thanks, Jim, for reminding us that chat is disabled. So please, if you do want to get a hold of us, use the Q&A feature. There's a small speech bubble with a question mark down at the bottom of your Zoom interface. But we do have three questions. One, I think I'll address privately for sales contact in North Texas, particularly the DFW area. But Jim also mentions, if you have a customer that wants to add wind and PV and take the PV system off grid, how can any of the available wind systems connect to a solar grid tied and then eventually an off-grid system? Have you seen some experience with that, Daniel?
Yeah, so the Solark, I think, is uniquely positioned, right? That you can take that wind and actually feed it into the Solark. Now, I will say this, that it's not very common anymore, and I would reach out to us and we can talk some about the specifics, especially if you want to combine solar and wind together. Where would we land that? What would we do? But I have heard from Solark, John Cromer over at Solark absolutely says that they can support that. Sometimes with the wind and with the micro hydro, you have to have separate controllers. And a lot of times what we see is what we're going to do is we're not going to necessarily take the wind or the micro hydro directly into the solar. We're going to have a separate charge controller that's charging up the batteries and supporting the batteries that way. Reach out to us and we're happy to talk a little bit more in depth about that.
And I'll keep that question for you to review maybe at the end, just in case I didn't quite phrase it correctly. But we have another comment maybe similar about sizing and recommendations. For a potential customer in an off-grid system asking why is it better to install batteries instead of connecting an electric vehicle to the house and use it as a backup? You know, obviously you've seen the trends of trucks and EV vehicles being able to power the home. What types of thoughts do you have around that set?
Yeah, absolutely. And we're seeing that become very common, right? You got an electric car, you have 100 kilowatt hour battery sitting right there. And I do see that becoming more and more common. So I think, you know, for maybe an off-grid system, maybe you go down to the Tesla charger and you got one of those free subscriptions and you charge up your car, drive it up to your home, and then you power your home off-grid. Maybe for somebody that's on grid, right? You got a battery in your car. I will say this, that we're still developing that kind of architecture. What does that look like for some of the interconnection policies? A lot of these, you know, for me, if I had an electric vehicle, I would absolutely could leverage my battery during an outage if I was grid tied to backup power the home. Would I want my vehicle, though, to drain its battery in an off-grid situation when I might need to drive somewhere? I'm not sure I would want to use all the capacity. And I'll also argue this, that a lot of times, especially with these new net metering policies, I'm driving to work, but my solar is on my home. and my solar is on my home and I don't have a net metering policy, I can't charge my electric vehicle, right? I need to be able to charge batteries that are on the home and then discharge those batteries to the home loads and then program my car to probably start charging, late at night after some of those time of use rates have happened. But it is an opportunity, and I see that kind of as the next step in our industry is leveraging electric vehicle batteries. A lot of them are cobalt-based chemistries, which they're starting to switch to LFP. And also all batteries, including ours, have a finite cycle life. So I'm not sure that I would want to leverage the cycles in my electric vehicle to support grid arbitrage or time of use, but absolutely maybe doing a backup for our home. I hope I addressed that. If you guys want to clarify or we can have a further chat about that, go ahead and put that into the Q&A. Mike, any other questions?
Nope, that's it for now. Thank you, Daniel.
Yeah, looking forward to that. And I have heard from John Cromer the ability to do, vehicle to home, not necessarily vehicle to grid. That's going to be a huge opportunity in the future. Maybe we could get out I shared earlier, Mike, the Briggs car and that Jay Leno had driven. Maybe we could hook that up to the grid someday. We're getting a little more advanced here, right? So we still have that same DC architecture. But now we've added an inverter. I got a Morningstar Sure Sign inverter there. So we still have solar panels, DC coupled into that charge controller, DC coming right back out, charging up those batteries. I still have some DC light bulbs and a DC fridge, but now I've added a small inverter, right? So it's kind of a hybrid of both AC and DC together. I can power up some of those AC loads like that microwave you see there as well. I think this is probably where most off-grid systems are now moving along. With the advent of a lot of these hybrid inverters, we're able to now power the entire home. Built-in charge controllers, built-in automatic generator start, built-in inverter charger, all in one package. We take solar, we feed it into that solar. We're still DC coupled on the batteries right here, which makes it more efficient. Charging up our stack of our 6.6 batteries there. Quick install, reliable. And then what we also leverage is one of our generators. What you're looking at there is our Briggs Stratton Power Protect 13K generator. So these are the propane or natural gas, but I'm guessing if you're living off grid, it's going to be a propane. And then what we do is we feed that all into the solar, and then we're able to support the entire home load on AC. No more DC Sunfrost or Stecas on there as well. But interesting to see how we've kind of stepped up as we go along. I don't want to spend a lot of time here, but just keep in mind that these kind of portable power systems are still essentially an off-grid system. And I see a lot of people that live in apartments, that rent a home, that still want to leverage that backup power, or somebody maybe in a camper. We got a lot of success using our batteries in campers, especially paired up with Victron pieces of equipment. We can still do that essentially, right? An RV is an off-grid system when you're dry camping. So let's take a step back, right? So again, I mentioned this at the beginning of the talk, that the loads really are going to drive the size and the cost of a photovoltaic system. So if you have wood heat, propane fridge, propane stove, propane heater for the home, and usually heating your hot water and heating the space is going to be the biggest driver of the size of the system. It's going to be big and expensive. Or it's going to be cheap and easy, right? But if you start to move over to those electric loads, it's going to become more expensive. I love this picture up in the top right, right? We got somebody that has a wood stove, but they're also cooking with it. And you got one of those fans right there that's blowing. I think it's like a Stirling engine in those fans that's blowing that hot air around the room. I got my Bico washer down in the corner. I got my 12-volt light bulb. I would argue this, that with the advent of lithium ion batteries that are reliable, safe, have long cycle life, living off grid doesn't have to feel like living off grid anymore, especially with also, in addition to the lower cost batteries that are reliable, lower photovoltaic prices, and also more powerful inverters. But do you know what's still going to feel like living off grid when you're living off grid is using a composting toilet. So or an outhouse. So if anybody's lived off grid and has used a composting toilet, please put that into the Q&A. Sunmar was a really popular one that has been in the market for a long time. So kind of as I hinted at there a little bit, if we are using propane to do a lot of our space heating and water heating, there are other opportunities. And one of the things I've still seen is solar thermal, right? We got some evacuated tube collectors over there on the left and some flat plate collectors. That's still, I think, an opportunity for a lot of people. There's no interconnection policies on a solar hot water system, and essentially, if you got a big water tank, that's a thermal battery that can be stored that energy and used later. I've seen these kind of not become as popular. If you still do these, please put that into the Q&A. But what's happened, right? Instead of me coming out to your house and putting plumbing, right? We're not plumbers. Maybe somebody's a plumber on this talk. Instead of doing plumbing and recirc valves and overpressure, over temperature blow off valves and pressure tanks, what we do is now we just put photovoltaics up on the roof, and then we use maybe the top element in a water heater, but leveraging these heat pump water heaters, right? So now we can take 1 unit of electricity that we produced up on the roof and turn it into 3 or even 4 units of hot water in a system. So solar, I think water heating's still a thing. I hope it's still a thing. NABCEP still has certificates for it, but now we leverage heat pump water heaters. I see the same thing kind of migrating over towards heat pumps for homes, especially now that there's inverter-driven compressors in a lot of these heat pumps that don't have that big surge that slams the inverter or the generator. Now it's much softer, and doesn't always have to be these little mini split systems with the thing hanging on the wall. There's ducted units as well that the homeowner knows no difference, right? They still have warm or cool air coming out of the vents in their floor as well. So let's just quickly refer to, why a system, a photovoltaic system, kind of operates off grid. If you're going to do off grid, a lot of times they have a lot of property and they do a lot of ground mount systems. But if you're doing rooftop, it's usually AC or DC coupled. If it's off grid, it's probably going to be DC coupled. Fixed orientation, probably going to be south facing. If you're grid tied here in California, a lot of people are moving towards west facing to kind of match up the production and the load profile of the home. But if you are off grid, right, you're probably going to do south facing. You're probably going to have a ground mount, fixed orientation, something similar to what you see there. So this is a grid tied system here, right? This is a 8,500 watt sun power system with 20 sun power systems. They're 425s, but you remember anybody who used to do sun power, they're N-phase microinverters. So I think there were probably IQ7 pluses, which probably had about 295 VA. So there's some inverter clipping, right? I'm getting ahead of myself, but you can see this picture here, right? This is on a March day, 8,500 watts, but the system right here in the middle of the day was producing maybe only 5,500. So what factors kind of contribute to a solar photovoltaic system array not producing its nameplate, right? So of course, in that March day, the irradiance wasn't as strong. The temperature was probably colder, which actually probably increased the voltage, which gave us a little more power. Shading can absolutely be a problem. The orientation, the efficiency of those maximum power point trackers, inverter clipping, which is kind of what I was hinting at with those N-phase microinverters, which actually is completely acceptable to have some inverter clipping. And it always kind of a tough conversation with the homeowner to explain why that is, right? You're clipping, but you're not losing much of the volume of that production. And also line drops, right? You're losing energy in your wires in heat because of the voltage drop. I just want to pause for a second here and just mention it. I still think it's pretty incredible that the sun being very far away, this ball of energy is still producing enough energy. A very small fraction actually hits the surface of our Earth, and we're able to capture that and turn it into 1,000 watts per meter squared. Although, right, it also doesn't hit our Earth evenly, right? If we're there on the equator, the sun's energy has less atmosphere to pass through. If we're further north or further south, the sun's energy is is kind of being absorbed by the atmosphere. Also, keep in mind the seasons change, right? So talking a little bit about having that off-grid homeowner, I think a lot of education goes into an off-grid homeowner, especially if they're used to living on the grid. Understand that in the winter, you're not going to have as much. Understand that if you wake up in the morning and the batteries are drained and the sun comes up and the batteries are full by noon or 1 p.m., go ahead and do the laundry. Go ahead and cook the turkey. You do whatever you want, because if the batteries are full, the solar's still producing, that power has nowhere to go. I do like that a lot of the hybrid inverters, especially solar, now have these smart load outputs that can automatically turn on loads like an EV charger, like the hot tub, when the battery stated charge reaches a certain threshold. So you don't have to always be kind of mindful of where you're at on the state of charge as well. This is kind of stepping back to what I was just referring to as air mass, right? The more atmosphere that the sun's rays have to go through, that's going to absorb more of that energy, right? If we were at the space station, we would actually get 1,400 watts per meter squared, and our solar panels on our space station would probably be optimized to collect some of the other parts of the spectrum that don't get absorbed through our atmosphere, to kind of increase the efficiency of our panels here. So we've all seen an IV curve. I don't want to keep kind of rehashing this, but one thing I did want to talk about is some of the factors we talked about: irradiance, temperature, air mass, is kind of tried to be modeled with our standard test conditions that you see on a back of a solar panel. One of the more kind of accurate ways to measure the production of a solar panel is the nominal operating cell temperature. There are other variations of this that give a better idea of what a solar panel is actually going to produce when it's in a real world conditions. Why are we talking about this? Is because we need to understand that if you have a solar panel out in the sun, it's not going to produce what it's rated for. And a lot of those become very important, especially in an off-grid system, when the power might go out. And in a grid-tied system, you're just going to have a bigger bill than you thought you did, but at least the lights will still stay on. Tracking, right? Back in the day when solar panels are $4.70 a watt, we used to, tracking was a big deal. And you can kind of see a picture on the right. Let me know in the Q&A if anybody still does tracking or used to do tracking. But if you think about, I got a bucket out in the rain, and the rain's falling into the bucket's starting to fill up. And if I start to tilt that bucket slowly to the side, when I start to tilt it a little bit, not much changes, right? The surface area of that bucket isn't really being reduced very far. But at some point, when I start to tilt that bucket, the rate at which the surface area drops isn't linear. And Nathan Heston, who's my boss, was a physics professor at Cal Poly, one of our top engineering schools here on the West Coast. He could explain this math a little bit better, but the idea is that if you get the solar panel essentially pointed in the right direction, you're going to get almost full production. It's when you start to tilt it away significantly that it drops. If anybody has done ZomeWorks was an innovative tracker. I don't believe they're doing these anymore, but the idea was that you had these 2 tanks of refrigerant on either side of the module, and as the sun heated this kind of pipe full of refrigerant, the refrigerant would boil off over to the other side and then tilt the array and track it. So I don't see tracking being very common anymore. Maybe I do see that in utility scale systems. Keep in mind there's single axis and dual axis trackers here, and you can see kind of the different angles that we're going to be talking about here in a second. So we're about to design an off-grid system, and one thing I wanted to do is maybe think about Mike up there. Maybe Mike has an off-grid cabin up there by a lake, and he's looking to do a home. So what I would do, and I found this book, the Solar Home book, here in the library here at Sunfrost. This book's from 1976, so it just goes to show you how long we've been thinking about this kind of stuff. But I went to the back of this book. I found that Milwaukee is at 43 degrees north. This book is at 48 degrees north, so we're close. Right now, Mike, it's about, I think, 1 o'clock your time. So I come down here to October 21st. It's close. It's the 31st, so we're about 10 days off. And I can see here the altitude, the height of the sun in the sky. I can also see the degree, the azimuth, or the degrees away from south. And I can also see here that I have the production, right? Normal is if I had the solar panel facing the sun continuously throughout the day. And then if I were to figure out, I see the highest number right here is that I would take the latitude, right, which is 48, and then I would tilt it up 10 degrees. So I would have the solar panel kind of facing the horizon, because as winter comes, right, that sun is kind of skirting along lower to the horizon. Why does this matter for off-grid? Because although you might not have a tracker that tracks the sun daily, we may want to have an adjustable array that we can do seasonal changes to the tilt. And you could see, based on some of these numbers here, what that appropriate tilt angle would be. And we, as you go further south, and if we get down to the equator or the tropics, the advantage of tilting isn't going to matter much. But the further north we go, absolutely, we want to start to tilt these things so we can capture some of the best array. Because if I look here, a lot of people say, latitude is a good one for grid tied because it's usually on a roof and you can't adjust it. A lot of this stuff, I know everybody on this call probably has Aurora, probably has Open Solar, probably has Energy Sage, but I think it's good for us to all kind of go back to some of the fundamentals and think about how we size and design some of these systems. A lot of factors go into it: temperature, latitude, the air mass, right? The angle of the solar panel pointing towards the sun rays. And again, this kind of holds true with the off-grid systems and on-grid. Power is produced when energy has a place to go. The batteries are full, solar's still producing, use that energy up. Let's size the system. This is an access system. We put a solar up top and we have some of our PHI or amplified batteries down below. What we're going to do is first figure out the load of the home. We're going to figure out the number of batteries and how big that battery bank needs to be. Figure out how much solar we need. Pick out a charge controller, pick out an inverter, talk a little bit about wiring. So here is Mike's off-grid cabin. I'm gonna just kind of make some assumptions. A lot of these off-grid cabins you're still using propane, Mike, for your space heating, to heat your domestic hot water, to cook, and you're gonna use propane for your generator. So I got some loads here, and you could kind of scale these loads up based on the home, and you potentially even just take a grid-tied home, look at the number of kilowatt hours they use per month, divide by 30, and get the number of total kilowatt hours per day. That's great. We know that, but we also want to look at how powerful of an inverter we might need to spec. So we're going to look at the continuous watt draw of the house, and also maybe what the surge might be if we have any motor loads in there. So we're probably not going to have this many light bulbs in the house, but I kind of put this as a placeholder here. Mike's house is using 4.6 kilowatt hours a day. What we know is all batteries aren't 100% efficient, right? 0.9, actually ours are probably a little more efficient than that. Most lithium ion batteries are, but we're going to lose 10%. Well, I'm sorry, the inverters, right? So on the inverters, inverters aren't 100% efficient. We're going to lose about 10%. So we know that we need to bump it up. Now we need 5.1 kilowatt hours per day. We're going to have days of autonomy. In the winter, there's probably going to be a storm that's going to blow through. We're probably going to be able to make it 3, sometimes 5 days is what we use for days of autonomy. So I need to take that battery and multiply that capacity by 3. Gives us about 15.3 kilowatt hours. All batteries, you don't want to discharge 100%, although on our new SimpliPHI 6.6 stacking battery, we do warranty to 100% depth of discharge. Unlimited cycles, no throughput warranty for 10 years. Great, one of the best warranties in the industry, but I would still recommend an 80% depth of discharge, so you still got a little reserve capacity in there. We're up to 19 kilowatt hours. It just so happens, I couldn't make this math up, that if you take 19 divided by 3.8, you get 5 of our 3.8 kilowatt hour batteries. It just so happens that a 3 stack of our 6.6 batteries comes out to 19.8 kilowatt hours. Great. We know how big of a battery bank we have. Next, we need to figure out how much solar do we need. NREL has a great maps. Again, we could probably do this in Aurora or Open Solar. But what this is a map of showing the number of solar or kilowatt hours per meter squared per day that we get, right? The number of sun hours is what we like to call it. This one would be great for a grid tied system because it shows it's averaged for the entire year. We don't want to use that for an off-grid system, right? Because we want to size the off-grid system for the worst month of the year. Maybe if it's a part-time cabin and Mike's only going up there in the summer, great. But maybe Mike, you're going up for ice fishing or something like that. You're going to want to size it for the worst month of the year. That's where this map comes into play. I found this one in the back of an old AEE solar catalog, and this is when catalogs were still a thing. And in the back of these catalogs, it actually had a lot of great information like voltage drop tables and these maps here. So we're looking here, and what we see is we got Milwaukee. I can see during the worst month of the year, they only get about 2 sun hours, right? The sun's up for longer than 2 hours, but if we were to take the number of hours of the day and kind of combine them into full sun hours, we get about 2. Let me know if anybody on the call is still using one of these. I love these things. The Solar Pathfinder. What we just did previously was figure out how much sun hours we get for an area based on the sun and the weather patterns. But now we also need to see if there's any shading concerns. And this was a great device that allowed us to kind of model that. You got to get out your crayon and draw this out. And if anybody hasn't seen one of these, it essentially allows you to look at a site and determine any of the shading here that might obscure the photovoltaic array during certain times of the day, and then quantify that by adding up these numbers here. So please let me know if you're still using one of these. I think it's still kind of a great tool. We're just going to assume that we have no shading. So remember, we used 4.6 kilowatt hours per day, and now we need to figure out how much solar panels we need. This is the battery efficiency. It's 96%. We're still losing coming in and out of the battery. I'm going to be pretty aggressive. Say we're going to lose about 40% of that array. Remember earlier we looked at that SunPower array. We were nowhere near 8,500 watts, right? So I'm just going to hack off 40% of all the production due to the system inefficiencies we just previously discussed, due to maybe some shading, maybe some of the tilt. And remember, we got 2 hours a day. So we need a 4,000 watt array. The math is down below. So if you take a 4,000 watt array and you put it out in the sun for 2 hours, you're not getting 8 kilowatt hours. You're probably going to get something closer to 4.6 kilowatt hours for some of these inefficiencies that we just identified. Great. 4,000 watts, what we need for our array. We need close to 20 kilowatt hours for our battery. Pick out a charge controller. Now, on the left, you see kind of an old Outback system where all the parts and pieces were kind of the charge controller, the inverter charger, the Mate 3S, the automatic generator start, right? We're all separate pieces. What's really exciting is these advent of hybrid inverters. Solar was the first one to go with. We are excited to be partnering with Solar, but there's others on the market that we are going to be working with as well. Absolutely, we got a 4,000 watt array. As long as we're working at 48 volts here, we can use our charge controller, that Outback. Also, we could probably bump it up to the FM 100. That Solar can do 13,000 watts, so absolutely we can still use a Solar. We need to make sure we have our charge controllers capable of handling all the photovoltaic panels that we're going to be putting in the system. Everyone, we have integration guides online that tell you how to program these pieces of equipment to make sure you treat the batteries correctly. Take a look at our website. The links are right there as well. Now we need an inverter, right? So what do you want in a nice inverter, right? Something that's efficient, doesn't use a lot in standby, can handle the surge, ideally outdoor rated, doesn't have to be, low cost, has the ability to start a generator. There's 2 examples here, right? You could absolutely still do something on the left, but now with the advent of hybrid inverters, many of them are on the market. You can now put all the parts and pieces into one piece of equipment. We got to make sure our inverter is powerful enough to handle the loads. Earlier, we talked about our continuous watt draw and the surge, right? Because of the power factor, right? One thing that's really going to contribute to the power factor is well pumps, booster pumps for your water system, refrigerators. So if we start to account for those VA, right, that what you're looking at, we know that we only got 2,300. We got a small system for Mike's cabin. We absolutely know that that solar can handle up to 9,000 watts continuous and handle up to 25,000 watts for 100 milliseconds. That's going to start air conditioners. That's going to start a lot of our big loads. So we're good sizing on that. One thing, if we are going to be doing DC conductors, like so that picture up on the right, that's an old Sunfrost, and that kid in the picture is actually my age. So that just shows you how long some of these old solar pioneers have been in the industry. But that Sunfrost refrigerator, when starting up, requires about 10 amps. 10 amps, great. Let's go ahead and get 15 gauge or 14 gauge wire. 14 gauge wire can handle 15 amps, no problem. But when we realize that we're only operating at 24 volts, there's not a lot of pressure going through those wires. We're going to need a lot more, kind of a bigger pipe or a bigger conductor to be able to allow that energy to flow with less pressure. So now if we start to look at this voltage drop table here, we understand that we need actually 8 gauge wire. So I think that was maybe also a reason why we moved away from some of that DC architecture. And now we're just running the entire home on AC as well. Here's our system. This is what I would put on Mike's cabin. And I would also argue that this system can also be expanded in the future, not only for solar, but also for batteries as well. We got 4.6 kilowatt hours, which Mike was using. We got our stack of 6.6 batteries, our 4,200 watt array, because I'm using some Canadian solar 300 watts. The charge controller can handle it. The inverter can handle it. One thing I did want to mention, though, is we need to run the panels in series to build up the voltage to make sure that we're operating within the operating parameters of our charge controllers. So in that solar 12K there, we need at least 150 volts DC on the solar photovoltaic side. We can't really exceed, I think it's 425 volts. So I'm going to have 2 strings of 14 panels, and that brings us up to 228 volts. It's going to be perfect, operating right in the middle of that kind of a charge controller operating window. Let's step it up. This is Mike's mansion off grid here. We've stepped it up. We're able to now take in 2 of our 6.6 stacks. Actually, the Solar 15K is great for this because it has dual battery inputs, so you don't need a midnight solar combiner or a Victron combiner or a PDU or any of that. We got our solar photovoltaic panels up in the right corner. We got the whole home backed up. We got a generator down on the right-hand side. That's one of our 22K generators. That's horizontal, either propane or natural gas. A lot of other calculators available. You don't have to remember anything I just said. Northern Arizona Wind to Sun has a great calculator. NREL will help you figure out the solar production. Again, one of the biggest things I think also, we're going to talk about this in a second, is replacing lead acid batteries in existing off-grid systems. Before we do that, I want to remind everybody that the 30% ITC from the IRA does apply to off-grid. There's another great website, Desire, DSIRE, USA.org, has a great website to help you navigate any other local, state, or even national rebates, incentives, not just for batteries, not just for solar, but for heat pumps, EV chargers, all of the like. So a great resource. Again, everyone's going to get a copy of this.
Hey, Daniel, if I could interrupt. So we did get a question. With all that we've learned from Solarc, we had a question about how well does the Solarc handle unbalanced load or high 120 volt loads?
Yeah, that's a great concern. And I think it does handle it to some extent, but I think it's really important. And I think that's a great kind of ethos in any of our, even in a grid tied main panel, right? We want to be able to show we balance some of those loads. You could put a fault right on the solar can only handle so many amps on one of the legs. So try to balance out the load center so that you're feeding kind of that load center evenly. Absolutely, great point, and it's something that we should always be looking at and paying more closer attention to.
One other item on the 100% discharge rate guaranteed by Briggs and our SimpliPHI batteries. This person's curious to understand the impact on the battery's health and lifespan if we were to design a microgrid to allow a deep discharge rate or 100% discharge. Is there any risk of potential thermal runaway in this scenario? And is there any preventative control to avoid the thermal runaway? So a couple of questions there for you to tackle.
Yeah, absolutely. I'll start with the, back in our lead acid battery days, and now even a little bit, we always would talk about the depth of discharge being one of the main contributing factors to a battery not lasting as long. And that's true, right? But one of the things that I think is impacting lithium ion batteries more so is the rate, the C rate at which we charge or discharge our batteries. The harder you're working the battery, even though you might go down to an 80% depth of discharge, can be one of the other contributing factors to shortening the life of the battery. The question related to the thermal runaway, I don't envision low depth of discharge contributing to a thermal runaway event. All of these batteries, including ours, have to pass 9540A. So if there is a thermal event, it's not very catastrophic, right? We're leveraging lithium iron phosphate chemistry. Again, 100% depth of discharge is warranted, but I would still recommend an 80%, just so that when you're hitting that low battery cutout voltage, you still got a little reserve capacity, so that it still has juice left to run the inverter, because the inverters all have that standby I talked about. But if it's a system that isn't really cycling a lot, sure, go ahead and get it to 100% depth of discharge. Absolutely, you can do that, and we still warranty for it. Mike, anything to add?
Nope, just doing a quick time check. We have a few minutes left.
Yeah, let's keep going.
Points.
Thank you. I'm going to skip ahead a little bit. You can replace lithium ion batteries with lead acid batteries as long as the equipment's pretty new. And you can, some of this math in here shows just how few batteries you can actually do. A lot of people complain, oh, I don't want to spend all that money to replace my lead acid batteries. Just give me more lead acid batteries. Keep in mind that you can get a lot more life and a lot more cycles out of these lithium ion batteries compared. Mike's going to have a problem with cold weather up in Wisconsin. We do have heating solutions. Our new 6.6 stacking battery has a lower operating temperature without the need for heating pads, which we do have as optional, and allows you to not use some of those heating pads. You can go down to 14 degrees. Really excited to partner up with Solar+. We're an American company. Briggs Stratton has been around for 115 years. Solar+ is another American company. That being said, we do partner up with a lot of other inverters on the market. Even at 100% depth of discharge, we're still offering 6,000 cycles at the C/2 discharge rate. At C/1.3333, we can still offer 4,500 cycles. That's like 16 years or 12 years. So again, you notice here, I'm not changing the depth of discharge. I'm changing the rate at which I'm cycling the C rate, which actually dictates my cycle life more so than depth of discharge. This is a great looking battery. I know we're coming up. We got 2 minutes here, everyone. We're on the last couple slides. I think with a lot of the things in the industry being all things equal, everybody's using LFP. A lot of people can do the quick discharge, although we're pretty proud of our 1C discharge rate. Looks matter. If you're going to hang something on somebody's wall and it's going to be in their garage or their side of their house for 10 years, for 15 years, you're not there, right? You're back in the van doing another job down the road. Homeowner's going to look at it. Don't forget to mention the looks, how it's going to look. We have a lot of assets that we can share with you to share with the homeowner. Looks matter. I would also argue install time matters. And with the stacking technology, everybody has a stacking battery now. One thing that sets us apart is that there is no conductors and communication cables on the side. We have a rapid stack connector that stacks it up quickly. We say 5 minutes, but really with the bracket and everything, I'm going to be a little more honest with everybody. It's about 15 minutes to install. Really quick to stack these things up. Of course, we still have our legacy batteries that are great for lead acid battery replacements. We also have high voltage modules as well. I'd be remiss if I didn't say how excited I am about our generator lineup. All propane natural gas generators. These are all air cooled on the left there, and then we step up to the commercial side, which is liquid cooled, which can handle 208, 480 three-phase as well. We do have transfer switches available. They may actually be leveraged in some of the grid-tied situations, even with the solar. We're on the top of the hour. I do want to just quickly mention that a lot of generators are not warranted for off-grid use. A lot of inverters and batteries are not warranted for off-grid use. Both our batteries and our generators are warranted for off-grid use. When you do use a generator in an off-grid situation, the warranty just changes a little bit. It goes for a number of years to run hours. Really excited about the 6.6. It's very innovative, easy to install. We have great IT support. It's a well-known brand. We're a world-class company with a world-wide presence, US-based company, and we're, again, an agnostic battery. Okay, thank you, everybody. If you're looking for your NABCEP credits, please email energystoragetraining@basco.com, energystoragetraining@basco.com. I'll be sure to get over your NABCEP credits. There's my email. There's my phone number. Please call me with any questions. If you're going to be doing your first time 6.6 install, we'll get you $1,000. I will personally get on the phone with you and help with any design questions. I'll be on the phone with you for the commissioning. We also have application engineers available as well. Happy Halloween, everybody. Mike, thank you so much for being here. Is there any last questions? Hearing none, we'll go ahead and end it. Thank you, everyone, again.